We have started this batch today, and we will try to complete it by 10th January. If you have any problem, you may contact me at any time. As you are aware, I am PK Mishra, Director Construction Industry Development Council, and a coordinator of this NLIP, National Level Internship Program. For this session, this is the inauguration session, let me say, we have invited a very senior expert, Professor Dr. Niranjan Swarup. He is Director General of Indian Society for Trenchless Technology. You may be aware about the trenchless technology. Sir will give you the brief of the trenchless technology in his sessions. And he is extraordinary expert in the subsurface construction and the other high technical projects. In I will share his brief profile to all of you in the WhatsApp group. But try to understand the level of his expertise. Uh, I am just giving the some brief points. Basically, he is currently the board member of various professional bodies like Engineering Council of India. He is board member. Try to understand the level of the bodies like Engineering Council of India, International Council of Consultants, the Council for Application of Actuarial Science in Risk Management in Construction and Allied Industries, CARAM. He also represents India on the board of several international organizations like Asian Forum, Asian Concrete Construction, Concrete Institute, International Council of Consultants. He is nominated member of several consultative committees like Bureau of Indian Standards. So this is very prestigious portfolio, NDMC, etc. He is the member secretary of several task forces and working groups for different bodies. He is the prominent of them are the Jawaharlal Nehru National Urban Renewal Mission (JNNURM) and the National Council for Vocational Training (NCVT), apart from others. He has very good and I am repeating my word, extraordinary experience and knowledge in the construction and in the other fields and in subsurface technology. So, on behalf of Construction Industry Development Council, I invite today's expert, Dr. Professor Niranjan Swarup, sir. Please, sir, take the session, sir. Uh, for brief, uh, for brief, I am just giving the input that we have 35 students joined in the civil engineering branch for the national level internship program. So now, sir, please take the session, sir.
Thank you, Mr. Sir. And a very warm welcome to all the boys and girls who are uh, going to be with us for this period till uh, we conclude this particular internship. And as per the course requirement, you would require to submit its completion certificate to your institution. Please be very, very careful about attending the classes because your presence is essential for these attendance certificates. If you are not joining the classes, certificates would not be issued to you. That is the basic background behind this series of program. Now, what we are going to do or we are going to talk is to begin with, I want to create or give you the basic perspective of engineering. All of you are going to become an engineer the day you graduate from your college. Now, I'll be talking principally on the engineering per se, that what is engineering, and what is needed for you to become an engineer. Yes, there are some suggestions. There will be some situations which I'll be posing to you, and I'll be asked those on those situations. We will talk about what are the solutions. So let me start the presentation. Window, this one, share. Oh, stop share. Window. Share. All right. Is my present slide visible?
Yes, sir. It's visible.
Yes, sir. Yes,
That's
sir.
visible. Hold on. I think there is some issue. Just give me a second because the system hung. It has decided not to run on the PowerPoint mode. So I'm like presentation mode. So I'm running with the slides. All right. Now, this is the 6th batch of NLIP, and I'm Dr. Niranjan Swaru. I'm Director Higher Education, CIDC, and Director General, Indian Society for Trenchless Technology. We will be talking about role of engineers in the complete industry. This talk is structured into 6 sections: Introduction to Engineering, Engineering Fundamentals, Engineering Profession, Role of Engineers in Industry, Solution of Overarching Problems. This is something which basically will give you thinking ideas how you are going to do the things, whether you are whatever branch you are in, whatever work you do, and then we will conclude our discussion. So let's start. Introduction to Engineering. This is the first section. Now, who is an engineer? Engineer is a person who uses the forces of nature for the benefit of mankind while planning, designing, or creating systems and structures. If you go and find the definition of engineer, you will get a very, very erroneous definition in the dictionaries. But then, this definition was coined somewhere around late 1800s, and this holds very good definition of an engineer. As an engineer, you are going to use the nature's forces to create structures or systems or methods which benefit the mankind. You're making a building. There will be a slab on the top. There will be walls on the side. The slab on the top will have its own weight. There will be a gravitational pull which would come onto the walls, and wall would kind of support it. Now, this particular edifice will create a space where people can live. So that is the primary roti kapda or makan means a makan. Okay. When we talk about roti, there are many things which you would be doing. You will be taking out the agricultural produce, converting them into eatable material, and then and for all these processes, there would be a part of engineering which goes in. Everything that goes in is the characteristics of an engineer. And our internship or our interaction, what we are doing with you, I am sure this will help you to gather that kind of capabilities so that you are able to deliver the desired results to the society. And that is what is an engineer. Now the genesis of engineer word comes from ingenium, which means the product of a genius. We expect you to be a genius. It went into ingeniere, and ingeniere means to create. So you will be creating some kind of system, structure, design, codes, or whatever you're doing. You will be creating that. And the person who does that is an engineer, creative and ingenious person. I hope all of you are creative persons. And if there is anything lacking in you, you need to cultivate that so that by the time you graduate, you are able to deliver solutions to problems posed to you. So that is what an engineer is. And I expect, or we expect, that all of you are going to become a very, very successful and confident engineers. Now, if I define engineering, engineering is the application of mathematics, empirical evidence and scientific, economic, social, and practical knowledge in order to invent, innovate, design, build, maintain, research, and improve structures, machines, tools, systems, components, materials, and processes. If you find definition, I mean, if you look at the dictionary against engineering word or engineer word, what you will find is this particular definition. But then it does not actually personifies you, which we want you to be. Engineers use the knowledge of science and mathematics gained through engineering education, experience and practice, applied with the judgment to develop ways to economically utilize materials and resources to the benefit of mankind. Okay, this is a long elaborated definition, but the basic definition was that single line which I spoke in the first slide. Engineering involves activities such as the conception, design, development, and formulation of new systems and products through the implementation, production, and operation of engineering systems. Engineers often work closely with the scientists and technologists in developing new products and technologies. So basically, this is what is the process of engineering. Now, let's move ahead. What is the role of an engineer? Engineer does three practical things: analyzes, designs, and constructs. Okay. Now, what is analysis? When analyzing, engineers are commonly required to verify, suggest means to comply with regulations or ways to improve the performance of a system, and in doing so, they seek to achieve the performance goals. So basically, you would be looking at a problem and analyzing it, or looking at a requirement and analyzing it, kya karna hai, what to do about it. And if you are able to analyze it, you will be doing a proper work and your role will be justified. Designing. In designing, engineers face the need of creating built environment, and this typically results in conflicting objectives of professionalism, developers' interest, and resources. If you are talking about an engineer working for a developer, developer's intent would be to to maximize his revenue, and the engineer's role would be to deliver something which is the best possible solution for any requirement. And that kind of requirement and the deliverance gets into the way, and there are conflicts, and this is where an engineer plays a proper role. So that is what is the second role of an engineer. The third role is construction. Building anything, it could be structure, it could be systems, it could be codes, it could be anything that can help the world, that can help the mankind. Finally, during the construction, an engineer faces the need to allocate labor, equipment, and materials to reach the given milestones in time. However, timely achievement of such deadlines require more intensive usage of the resources mentioned, which triggers project cost. So basically, your role would be, so once you have analyzed, designed, then implement. And while you are implementing, you have to use the resources and optimize that. So all these go into the role of an engineer. Now, this concludes the first part of my presentation. Now, how do you do it? There are few basic engineering fundamentals, some of which you have studied right from the class 5th to 10th, 12th, or whatever classes you have gone through. And those have been channelized so that you can apply them in finding a solution for an engineering problem. So these are the engineering fundamentals. These would be the dimensions and units, length and length related parameters, time and time related parameters, mass and mass related parameters, force and force related, temperature and temperature related, energy and power, engineering drawing and symbols, computer-aided designs, statics, materials engineering, design and analysis, electric circuits and components, engineering economics, probability and statistics, and computer programming. All these are part of your portfolio, and this is what are the basic engineering fundamentals. I will be briefly just listing them or listing the subcomponents within these fields. What we expect as CIDC or as the industry, that you people should have adequate understanding of this, and that understanding needs to be applicable to the project site or works or industry or manufacturing units or wherever you're working at, computer company or whatever. No, let's go to the first one. Fundamental dimensions and units. The engineering problem and fundamental dimensions have a clear-cut relationship. If you have to design something, if you have to calculate something, you need to understand the dimensioning of that. You need to have the basic understanding. Say, for an example, you're talking about a slab. If it is a slab which has to be designed, you need to know its area, and that basically means you need to know the complete dimensions and all. Then what you need to know is how you are measuring it. Let's say you are working in India, you're using SI system, but if you travel to the United States, your measurement will change to FPS, foot pound and second system. The moment it goes to FPS, all your measurements will change and all your calculations, your parameters will alter. So basic understanding an engineer has to have is a system of units. Then unit conversion. How would you convert it? Let's say you studied your engineering here in India, and you went yourself or you work with CIDC for any overseas engineering admission, because we are working with several of United States universities. So if you go there as a student, you'll be faced with a situation where you'll have to be changing your thought process from SI unit to FPS unit. So unit conversion is the next thing. Dimensional homogeneity. How does the whole process dimensionally works out? Numerical versus symbolical solution. In engineering, you'll not have a straight 1 to 1 or 2 plus 2, 4 solution. You could have a different progressive solutions which would be changing. So you should have the basic understanding of numerical versus symbolical solutions, engineering components and systems, that what are the basic component systems that you have to understand, you should know. Physical laws and observations in engineering, that should be with you. Learning engineering fundamental concepts and design variables from fundamental dimensions. So basically, from the measurement side, you need to go ahead. Let's say you are constructing a building, you are constructing a bridge, you are making an equipment, you are making a component in a manufacturing unit. Everywhere you'll have to have that measurement understanding, and that is the fundamental dimensions and unit. Similarly, if we simply migrate that to a more precise point, what we are talking about, the length and length related parameters, which is the length, measurement of length, nominal sizes and actual sizes. See, when you are having a pipe will have a nominal diameter and actual diameter. The actual diameter would have the thickness added to it. The nominal diameters would be the dimension inside a pipeline. So basic understanding of what you have or what you require. Then comes radiance as a ratio of two lengths, strain as a ratio of two lengths, area, volume, second moment of areas. I believe all of you have studied these, or you will be studying in course of time, but generally these are from the initial part of engineering, so I believe you must have studied all these. Time and time related parameters, that time of the fundamental dimension, measurement of time, periods and frequencies, flow of traffic, engineering parameters involving length and time, and angular motion. All these would define many of the engineering solutions of problems. As an engineer, you need to have these basic understanding within your mindset. Mass and mass related parameters, they cover as mass as a fundamental dimension, measurement of mass, density, specific volume, specific gravity, mass flow rate, mass moment of inertia, momentum, conservation of mass. All these basic understanding should be with you. If you have those understanding, you will be able to work out solutions to given problems. Force and force related parameters. Here again, what we mean by force, Newton's law in mechanics, moment, torque, force acting at a distance, work, which is the force acting over a distance, pressure and stress, that is force acting over an area, modulus of elasticity, modulus of rigidity, and bulk modulus of compressibility, linear impulses, forces acting over time. So if you have the basic understanding of these particular parameters, these would help you to calculate, evaluate, or rather design or analyze a problem, design something and construct according to your designs. Then comes temperature and temperature related parameters. Here also, what you have is temperature as a fundamental dimension, measurement of temperature and its units, temperature differences in heat transfer, thermal comfort, metabolic rates, and clothing insulations, some temperature related material properties, heating values of fuel, and degrees, days, and energy estimation. All these would come into play as we will be seeing at the later part of this presentation. Energy and power, the work, mechanical energy, thermal energy, conservation of energy, and that basically laws of thermodynamics, that you cannot create energy, you cannot dissipate energy, and all that enthalpy and entropy. Those three laws you have to understand. Understanding what we mean by power, watts and horsepower, efficiency, and energy sources and generation and consumption. Engineering drawings and symbols, I believe most of you must have gone through these papers or like these classes. You have to know what are the importance of engineering drawing, what are the orthographic views, dimensioning and tolerancing, isometric views, sectional views, civil, electrical, and electronic drawings, solid modeling. Why do we need engineering symbols? This is also one thing which you have to understand, or which you have to have that basic understanding. Examples of common symbols in civil, electrical, and mechanical engineering. So these things come in your engineering drawing and symbols. Then comes computer-aided design. Computer-aided design, that is CAD, is the use of computer program to develop 2 or 3 dimensional 2D, 3D graphic representations of physical objects. CAD software is used by architects, engineers, drafters, artists, and others to create precision drawings or technical illustrations. The software performs calculations for determining an optimal shape and the size for a variety of products and industrial design applications. CAD is also used throughout the engineering process, from conceptual design and layout of product through strength and dynamic analysis and assemblies to the definition of manufacturing methods. This allows an engineer to both interactively and automatically analyze design variants to find the optimal design for manufacturing while minimizing the use of physical prototypes. Statics. This is something which goes as a core for most of the engineering. You need to understand the scalars and vectors, the equilibrium of forces, moment, couple, torque, free body diagram, centroids and center of gravity, moment of inertia. If you have that understanding, your life will be very, very easy or simple. When you are working at any project site, you are working in any factory, any establishment. Similarly, when we are talking about materials engineering, here also your need is to know how a material is going to behave. So you need to know what is the properties of metal, ceramic materials, polymers, and composite materials. Those material understanding will help you. Say for an example, if you have a beam and beam has a load which is cracking down, One of the common solution today is that you apply FRP reinforcement at the bottom of the beam. So what happens? This FRP solution or this FRP pasting starts taking some of the tension which is being transferred on the steel bars at the bottom, and that tension will help. I mean, like reduction of that tension will help the structure to survive. So you should know what is the behavior of that FRP sheet which you are going to place, and how you are going to paste it, and how it is going to take the load, and where it is going to transfer. That you have to understand. All that comes under material engineering. Design analysis. This is the next step when you have understood everything. When you are doing, all you have to understand is basically stress and strain, uniaxial loading and deformations. All these parameters, what you are listing here, you need to understand that and basically be able to find material or components capable enough to take that kind of address that requirement. If you are talking about the stress and there is a tensile stress, we need to put enough tensile material which can take that kind of stress without going into plastic deformation. And that basically will come if you understand what is the design and analysis. Electrical circuit and components. Here again, these are the basic components, electricity, circuit components, all this. The presentation will be shared with you once this class is over. So I'm just not reading this, but these are the things I expect you to understand and basically use them in your future life. If you use them, you'll be successful engineers. Now comes the money matter. Money is a very major issue for all the engineers, because if you are not uh, managing a project financially or economically, your project is going to go haywire, and there is a possibility that your project or your works may not complete. It would be lost. The engineers are involved in management of projects ranging from single product development to complex projects that require financial decisions, making the making to maximize the economic value of the product or project. Knowledge and understanding of the tools and techniques necessary for making economic decisions are essential for all of you. And believe you me, these are something which you have to cultivate within yourself. If you will do this, you'll find good employment, you'll find good occupation. If you don't do this, you will be just like somebody who's put onto some kind of what do you call clerical job. So basically, where I'm taking you is you should know the interest impacts, you should know the effect of time and interest of money, you should know the present worth, annual worth, future worth. There are standard analysis systems that you should know. Rate of return, there is a ROI, return on investment, there is a ROR, there are several returns. You need to understand what is going to be received if you do some work, and based on that, you should have the understanding how to decide. That basically helps you to become complete engineer. The engineer has to take a call, has to see the situation, analyze and decide that this is what is to be done. That basically means he is designing the structure or designing the process. And the moment he decides it, the job is done. And that is what we expect from you. I hope you will be with me. Now, another issue which comes in is the probability and statistics, because you will not have the future reference for many things. What you will have, references of the past, and those references need to be assimilated, and based on that assimilated and evaluation, you will be making guesses that, okay, this could be the result of this kind of situation or these problems. So you need to know the probability, the statistics, then statistics in organizations and data. These things are quite important for the engineering profession to move and grow. So basically, if you have these fundamental understandings, you will be able, or you will be good to go, and you will be my man or my lady for the project or for the engineering application. And I welcome you, because I know that your engineering colleges, your institutions have been teaching you many of these things. And if you haven't studied these, please pay attention, gain this knowledge, and move ahead. Now, what would you become? you would go, like you will be functioning as a professional. And what is the engineering profession? Let's talk about that. Engineers are problem solvers. You are supposed to be solving any issue, any problem. Successful engineers possess good communication skills and are team players. If I am a successful engineer, I will have a good communication skill, because all the things might not be done by me, but I can talk to people, I can talk to my teammates, and part of it, which I am not doing, they can do. And in the team, the whole job can be completed, or whole work can be done. They have a good grasp of fundamental physical laws and mathematics, as we discussed in the last section. Engineers apply physical, chemical laws and mathematics to design, develop, test, and supervise the manufacture of millions of products and services. They consider important factors such as sustainability, efficiency, cost, reliability, and safety when designing products. Engineers are dedicated to a lifelong learning and service to others. You will survive as an engineer till you continue learning. There's a continuous professional development which you have to embark upon. आप सीखेंगे तभी बढ़ेंगे, नहीं सीखेंगे obsolete हो जाएंगे. The obsolete होना, or obsolescence, is something which kills the engineering steam in people. Keep yourself alive and you will be growing. Now, if I talk about the engineering profession, there are three different sections as we talk: engineering and society, engineering ethics, and communication and teamwork. So let's talk one by one. When I'm talking about engineering and society, social influence in a globalized world. So basically, an engineer has to provide influence to the society from the global world, gain the information from total world, and bring it to the local social requirement. Evolution from social norms and technology. Based on his inputs, the things would change. You will create, let's say you are creating a toll road. The toll road means people will start traveling on that. Their velocity or their vehicle speeds will grow. And if that speed grows, they will be able to transport their producers to a bigger market, and that basically will evolve, will basically help in your local area. There will be political influences. Then there are issues like, say, God forbid, a bridge collapses. Mumbai, there have been bridges which have been collapsing. You know why? The bridge was made about some 20, 30 years back, and it was not maintained. And the load on that went on increasing. Like this, I believe the place is called Elphinstone. The bridge collapsed and people died. Now, based on that accident, things have been involved. Now, CIDC is creating a bridge inspector program which is open to engineers who learn about it. Now, this bridge engineers program would basically tell engineers what to do in case you are looking at a bridge. How do you check the bridge? You report where the things are going wrong, and if the things have gone wrong, get them rectified. Do you know we construct close to about 4 lakh crore rupees worth of structures every year? These 4 lakh crore rupees worth structures need to be maintained every year. And if I simply look at the last 20 years, that is, if I start counting my structures right from year 2000, from 2000 to 2021, we have constructed not less than 80 lakh crore worth of structures. Imagine the maintenance need for all those structures. Let them be a bridge, building, anything. And you require people who can look at the thing, who have the understanding how to find anything failing, get them rectified, and based on that failures, they can provide solutions. They should learn from the failure tragedies, and on the basis of that, provide solutions so that those structures are given extension of the life, or new lease of life. So that is engineering and societies. Then comes ethics. You will be in a position to take a decision, and that basically means that you can take a decision which is good for the society. You can take a decision which may not be good for the society. You have to have that ethics. So there are basic ethics in engineering education, you should learn that, and there are basic ethics in engineering profession when you are rendering services. So that has to be within your understanding. And obviously all this you will have to learn while you are becoming an engineer. For your information, Engineering Council of India has established ethics for engineers. Do go to its website, it is ecindia.org. Look at the website and you will find what are the ethics. Learn that and believe, I mean, like, practice, hope to practice that in your profession. Path to resolution of an ethical dilemma in employment that provides this, that code provides that path. Seeking advice and reporting concerns and violations. There are whistleblowers, if you are aware, and those whistleblowers are the people who basically follow the ethics. And if they find that something is wrong, they come up with the what do you call uh, information to people, or basically RTI and all those things. But you need to understand where to be the whistleblower. Other questions to consider before employee takes action. So all these comes under engineering ethics, and you need to cultivate that within yourself. The last part in this is communication and teamwork. That is the essential soft skills in the globalized workforce. I work as the Director General of Indian Society for Trenchless Technology. Trenchless technology is a business of constructing, maintaining, and replacing subsurface assets without excavating continuous trenches. It's something like tunnels. When you're making a tunnel, what you do is you will be putting some kind of equipment which will excavate soil from the surface, ground below the surface, take it out, and a cavity is created. It is like putting in a liner, and that liner can be created from the end and pushing in. It is like repairing that liner if the liner has gone bad. It is like replacing that liner, that is pulling it out and placing another liner. All this is a part of trenchless technology business which I profess. Now, that business is not Indian alone. That business is functional across the globe, because you will have the water supply line, drainage line, telecom line, gas and oil lines, all the pipelines which are buried below the ground everywhere in the world. So all the problems which are faced in India are faced in other countries also. And every country is developing their own things. And obviously all those things come into this domain, trenchless technology domain. And me as an engineer or trenchless engineer have to work with those people to collect that information and provide that to Indian professional engineers. Like, take for an example, some of you boys and girls, if you desire to become a trenchless technologist, you would require that information. And I need to be, not only me personally, but I need my team to be having proper soft skills in gathering that information, transforming it for our usage and apply here. I need to have oral communication capabilities. Like I'm speaking to you, I hope I'm able to convey what I want to say. And I hope आप लोग उसको समझ रहे हैं. You are able to understand all this. If you are, then I'm successful. If you are not, sorry, that's my mistake. But no, I know that you are understanding that, because end of this lecture, I will be talking to all of you. And if you have any doubts, we will talk. Written communication. You need to cultivate writing proper English, generally English, because globally English language is something which is understood and accepted. There are several shortcuts people have created while they are working on social media. They use poor English or bad grammar. That is something which you need to have, and you need to communicate. If you have a better communication, whatever you want to say here would be understood by a person outside. If you are not able to communicate that, all your knowledge, all your effort will be waste. Other technical communication mediums, you need to have, or you need to know how do you communicate. Then communicating by listening. You are listening to me without making a noise. Your mics are off. If you start making noises, or if all of you kind of what we call unmute yourself, It will be very, very difficult for me to communicate with you and very difficult for you to understand what I'm trying to say. So all that comes under communication. Then teamwork is essential. How do you work in a team? All the works cannot be done by one person because you will never have all the capabilities, all the credentials for everything. You will need somebody who's good at design. You'll need somebody who's good at execution. You need somebody who's good at procurement. You need somebody who's good at testing the material, who's good at the testing the quality of the structure. All those people put together, when they work together, the result is a successful project. And naturally, it is basically working together. The fundamental characteristics of effective teams and team members is this: leadership in teams has to be there, and all of you need to be leaders in your own domain. If you're working, let's say you like designing, and you're working for a design project, you should be leading the whole team behind you. Then comes embracing diversity. There would be people with different viewpoints, different inputs. You have to get them in, and when they all of them join, what you get is a more powerful engineering system. So all this comes under the engineering, rather the engineering profession. Now comes the role of engineers in the industry. You are studying engineering. What are you going to do in the engineering? Let's discuss that in this section. Engineering work is all around you. You do anything. Even these farm bills, if you are aware, the farm bills were created so that the produce of the farmers could be collected, stored, and then disposed of at opportune time so that everybody makes money. Now, when you are buying raw agricultural produce, it has to be stored in a proper manner. How will you store that? You require specific temperatures like cold storages. You basically require cold chain, because what would happen is the material which is frozen has to be brought back to some temperature, has to be brought back to some other temperature, then has to be brought back to some other temperature for usage. Now this chain of material heating up is a process for which you require a different set of structures, different set of operating procedures. There will be systems that, okay, fine, if I have, let's say, potatoes can be stored at this temperature. If I store them below that temperature, the potatoes can um, freeze. And if they freeze, the water in them will expand, and that will be basically spoiling the potato. So you need to store the potato at a particular temperature. And then you have to heat it up in a process that they don't get boiled up. They have to be heated in a manner. All that is engineering, which some of you might be performing. And not only agriculture, anything you think about, it could be ranging from uh, construction, it could be ranging from manufacturing. You think of it, and engineering is there. Engineers deal with increasing world population and sustainability concerns. Even the COVID, for which uh, there was one set of vaccines which required minus 20 degrees for storage. Now, those vaccines required to be transported from the manufacturing hub to the storage hub to the disposal hub to the hospitals. So, all this stage needed a set of systems, or a proper system by which you could bring those vaccines to this place. Do you know who would do that? Naturally, an engineer. And it is needed for the whole world. We are talking about more than 6 or 7 billion people who had to be vaccinated. Okay, the population is there. You require so many things, and the world has to be sustainable. Now, unfortunately, some of the nations decided to hold those vaccines. The net result was that some nations did not receive the vaccines, and if they did not receive the vaccine, the the virus in those nations mutated, and the new mutation, like this Omicron, has come in, which basically is again threatening those nations who had hoarded those vaccines. So basically, there has to be sustainability understanding in the engineers. Engineering as a profession and common traits of good engineers are basically something which you have to cultivate in. Now, what are the definitions of engineers? I mean, like disciplines of engineering. All of you are aware. I've just listed some of them. All these people are going to function as a different professional in different field, and I'm sure all of you would be moving into these streams one day. Please do that. Engineering profession is inherently multidimensional and multidisciplinary, and the lines between each subdiscipline blur. I'm talking about trenchless technology, which is my business. In trenchless technology, there is an equipment by which I conduct the subsurface investigation. How do I do that? There are electromagnetic or radio frequency waves of high intensity which are sent in the ground. They will go and hit an object and get reflected. The time of this movement is measured by that equipment, and that equipment is called GPR, ground penetrating radar. Now, if I run ground penetrating radar, I would know what anomalies are there in the ground. And if I know that, I will be able to create my structure avoiding that. Because I'm doing trenchless technology where I'm not excavating open trenches. And if I'm not excavating open trenches and I'm drilling or I'm tunneling, there is an object in front of my drill or tunnel. This will get damaged. To protect them, I need to know what is there. Now, this particular knowledge requires, or this particular evaluation requires knowledge about the radio frequencies, electromagnetic waves. It requires geotechnical knowledge. It requires electrical knowledge. It requires programming, because what you would get is a signal of the reflection. Now, that reflection has to be measured, and that signal has to be measured so that you would know where the pipeline is buried. So one line I told you about survey of buried utilities. Then I'm talking about new installation. In new installation, when I decided that this is my installation path, this is where I'm going to place my pipe. What is going to happen? I will be using a cutting tool which will be moving. Now this cutting tool will get heated up if it is just cutting. So I need to have some kind of material to cool it down. What is going to be that material? That material is going to be bentonite or any clay slurry. That clay will be pumped by equipment which is a mud pump, or rather a circulation pump. That pump will send the mud to the cutting location, and which will basically cool my drill head or cutting head, which will bring the excavated soil back to the machine where I was sitting. So this requires understanding about the fluid mechanics. This requires understanding about the densities, about many things, because if I do not design my fluid, if I don't design my bentonite, it will be lost. Now, when it is drilling, I need to know where is my drill head, because I'm not gone inside. I'm tunneling or I'm drilling from the out. So, how do I know that? I will install a transmitter. Now, that transmitter has to tell me three things. It has to tell me its location. It has to tell me where it is going. It has to tell me what is its temperature. If it is heating up, I need to cool it down. If it is going in a wrong direction, I have to change the direction. And if I don't know where it is, then it's going to land any place and damage anything. So all these things can be known by placing a transmitter which is capable of providing me these three information. And how does this happen? I will have a magnet placed in my drill head. That magnet will have a magnetic waves which will be scattering, which will be moving all around the magnet, and that waves would be read by a system which is covering it. And this whole set of equipment is termed as a sonde or as a beacon. And that beacon or sonde basically catches the magnet's location and relays it outside. Now, when we are talking about these magnet signals will get warped because of the Earth's magnetism. And Earth's magnetism will force it to kind of change. And for that, we require some kind of rectifiers which can contain or which can properly inform me the location. And that, but all those things require some kind of wave engineering knowledge. Obviously, all those things are multidimensional. Another sector, I will say, when I'm running my machine, I'm actually applying a force onto the ground. This force will have a reaction, and that reaction would mean there is some kind of anti-reaction happening at the end, or like it's some action and some reaction happening at the end of the machine, and that reaction would basically heat up my machine. So I require whole of the system cool down. So I require some kind of understanding of the uh, heat transfer mechanism, which could be a business of a mechanical engineer, which could be a business of a chemical engineer. Whereas I'm a civil engineer, whereas I'm a mechanical engineer. So many things do come in. All those come into this business. Take for an example, if you have to install electrical cables in the ground, each electrical cable has a flux around it. And let's say if you put three cables parallelly to each other, the quantum of flux will be spread out on a larger area. And that flux is basically creating charges and can be harmful to human life or many things. So what is done is you place them in a triangular way or in a manner so that the impact is contained. It is in the least effective zone. And that basically means you need to have the understanding of electrical flux. Now I'm doing trenchless. I may be a civil engineer, but I need the understanding of that those cables and the flux around them. So all that is multidimensional, and I need to know. Engineering professional is a hands-on, minds-on activity. You need to be alive. You need to be ready to work with your hand. Engineering professions require integration of various skills of different fields. As I explained to you, there are so many fields, and all of those put together. Because if you don't provide bentonite at right point, your drill head is going to burn, heat up, and if it heats up, your magnet may burn, and if your magnet burns, your whole machine goes waste. So it has to be integration of all these skills which come in. Engineering success often is based on successful teamwork. There would be a person who would be designing the mud, there would be a person who would be running the machine, there would be a person who would be tracking the the drill head where the drilling is being done. All those people have to work together so that your drilling goes properly as you have designed. For designing, there was a team which basically ran the ground penetrating radar, and once they ran the radar, they told you that here is a pipe, here is a pipe, here is a pipe, and you will be laying your network avoiding those pipes. So basically, all these comes in. Then comes appropriate ethical behavior. If you know that the thing can be done in a proper manner and you don't do it in that manner for somebody else's profiteering or your own profiteering, that basically is not expected out of engineers. What we need or what we want is ethical behavior from the engineers. As I indicated about ECI website, please go there, have an understanding of engineering ethics. Engineering activities for success often depend on identifying the basic steps of design process, applying those basic steps to see simple designs, completing a successful team design project. So this is how you move in the uh, engineering profession. Now coming to construction engineering per se. A construction engineer is faced with either the design, construction, or retrofit of the infrastructure or building. That is what, as a construction engineer, you will do. If we look at structures, the engineers will look at use of the structures and categorize it as any of the 11 construction domains like buildings, road, bridges, buried structure, many things. You want the full list? Please go on CIDC website. There is a construction cost indices page on which you will find those 11 domains, that what are the domains and how do you categorize. And every domain will have a domain specific engineering understanding and requirement. For the designs, the engineer faces the need to minimize the size of foundation and the structure while restricted to standards specified by the norms and codes. Say you want to make you want to construct a building, and you are making a huge foundation which was not required. You're actually wasting money. You need to have them as small as possible. In addition, the engineers will look at the purpose of the structure and attempt to minimize the amount of space while still complying with the number of deliverable attributes and other elements as required by urban planning regulations and building bylaws. So all this goes into construction engineering. When the engineer is tasked with the design of infrastructure, he will have to look at either the surface or underground infrastructure and decide on the dimensions and features required as preconditioned by the demand or usage from the public at large. If you are making, let's say, Burj Khalifa, the Burj Khalifa's foundation was maybe 3 times larger in the uh, floor area matter, was more than 3 times larger than the floor and on the ground what Burj Khalifa has. All that was designed because we were talking about some huge structure and all the load, everything which was coming on the foundation. So all those had to be designed and evaluated. For these, the engineer may need to play the role of a planner, forecast demand for the infrastructure. Later on, the engineer will need to worry about how to maintain such infrastructure during its lifespan. Like the bridge I told you about the Mumbai. If the bridge was supposed to survive for, let's say, another 100 years, you have to plan how it's going to survive. What are the maintenance things you have to put? What are the condition assessment things you have to put? Like there are inclinometers, there are pressure meters which tell you that this section is being stressed. There are inclinometers which will tell you that it's tilting, it's collapsing. All those things need to be known. Now, basically, what are the goals? The goals, there are primarily two goals: minimizing of the resource utilization and achievement of a certain level of quality and performance. सबसे कम खर्चा करो और उसमें जो जो जरूरत है उतना डिलीवर करो. Means spend only that much which is the least required, without which you can't do anything, and get the most optimum result out of your investment. So these are the two primary goals of engineers. How do you do it? You take a decision for those, and when you're taking a decision, these are the elements. निर्णय जो आप लेंगे उसके लिए आपको ये elements देखने हैं. Applications or resources in any action results in an outcome of a certain utility. The value of this outcome, if measured, have the characteristics of decreasing the returns to scale, whereas the inputs continue to be invested. If you are, let's say you are making a parapet wall, and you are making that parapet wall 6 feet high, it will be waste. If you make it 3 feet high, it could be good. If you make it 2 feet high, depends. Might be good, might not be good, depending on what kind of protection you want around your terrace. So all that will basically define what you're going in, and you have to take a decision what you want to construct. Where do you want to spend your resources? Utility of any action is the core element of any decision, since the objective of any individual is to maximize his utility given a certain amount of resources, time, money, material, effort and ability. मेरे पास 100 रुपए हो और मेरे 100 रुपए खर्च किए बिना मेरा काम हो जाएगा. Nothing like it. If I have 100 rupees and my work is completed without spending any money, anything out of that 100 rupees, is a good solution. But then that may or may not be possible. So basically, what would be the best possible solution? That is what is the element of decision I have to take. Now, what are the objectives and constraints? Seeking the largest amount of utility or output is called maximization. You maximize what is going to be received. Minimization means seeking the usage of the smallest amount of resources is minimization. You minimize what you are investing. The amount to be minimized or maximized is called the objective. If you want to have, let's say you have a budget of spending 100 rupees. So you need to execute the work in 100 rupees, and that is your objective for the project. Restricting yourself to a given amount of some resource gives you a constraint. Let's say you need to spend out of that 100 rupees, 50 rupees on material cost, and your labor wages are going to be 55 rupees. Your constraint is the material cost. Now you have to find some solutions to bring back or bring down that 55 to 50 rupees. The constraint is the material cost. The amount of resource you will use is called decision variable and control variable. So this is what it would be the variable you will have at your disposal. Your amount of resources in this case was 100 rupees, and this is a decision variable which you'll be using, and how you manage it is basically your engineering logic or your engineering design. How effectively you use your time, your machines, etc., gives you parameters which are typically related to productivity. Say if your worker is capable enough to deliver an excavated volume of 1.5 cubic meter in 8 hours, and you are able to get 1.5 cubic meters, that means you are having a productivity of 1. But if you get less than that, that means you are less productive. If you're getting more than that, that would be a good outcome, but it could stress your worker. But if we go, and the same thing goes with the equipment. Equipment has a defined productivity, and if I get the same productivity, it's normal. But if I get more productivity of the machine, that basically means I will be stressing my machine to that level. I have to take a decision how much productivity I require and how do I achieve that. So these are the objective constraints. Constraints impose limits to the ability of the decision maker, and they restrict the universe of choices by considering what is feasible. For instance, producing a very large amount of ice cream may not be feasible because of storage limitations. Constraint can also limit our ability to combine resources, sometimes to produce goods or build others to achieve intermediate elements. The space of choice is delimited by the constraint is called feasible space. If I have, let's say, a place to store cement bags on my project site, and that space is, let's say, 5,000 bags, and I want to do concreting which requires 7,000 bags of cement, I might not be able to do it. So my feasible space is 5,000, and my productivity will also be linked to 5,000. I will never be able to produce more unless until I increase my storage space or I change my delivery process. Here is a term which I will like to mention. That's called JIT, just in time. Now, let's say I needed 7,000 bags. I had 5,000 storage capacity, so I will have 5,000 bags in the start. What I will do is I will plan as an engineer that my material starts coming in. Say I lifted 500 bags from my storage. There is a supplier ready to send me 500 bags, so that I go on replenishing it, and my stock reaches 7,000. That is the stock of 5,000 plus 2,000 installed. If I do that, my productivity will go up. Obviously, the feasible space still remains 5,000. In general, one requires a well-behaved feasible space as a request to solve an optimization problem and find a solution. What I mean by that will be the matter of another. For now, let's allow the loose usage of objectives, constraints, and decision variables. Now, what are the objectives and constraints? As a construction engineer, one will have to identify the objective as the most important element of the posed problem. Creating a decision model would be an identification of the very nature of the problem. Kya problem hai? What is there? Writing a mathematical formulation and solving it. There is, however, not a given formula to do this. As I gave you an example of that 5,000 into 7,000, there could be a process by which you would be getting those 2,000 bags in. Now that process means you will require some trucks. How many trucks you require, and what is the timeline available? What is the truck carrying capacity? All that put together will give you some kind of working scheme. And that working scheme will give you JIT process. Say you have 3 hours to replenish those 2,000 bags, and you have a truck which can, you have a trucking system which can transfer, say, 500 bags in 1 hour. If you have 3 hours, you'll be able to transfer only 1,500 bags. So what are you going to do? You need to have some kind of further solutions so that you get 2,000 bags, 500 more bags into the stock. Understanding a problem requires us to identify the features that we have control over and that by manipulating could help us achieve a goal. Problems typically involve multiple dimensions and considerations of other systems commonly need to be removed or simplified in some cases, in many cases. For any problem, look at its elements, write them down in blank piece of paper one by one and use arrows to connect them and brackets group them. Write them all down and somehow connect them. Continue by exhaustively enlisting possible combinations of resources and how they may be limited. These are the inputs given for solving or rather resolving the problem which you can do. Today what we're talking is a generic information to you. There will be many lectures, we'll be talking about these, but you will know about this or you'll understand this once you go to a project site and understand the basic working. Take for an example, if you're doing concreting and your concreting requires n number of masons, k number of unskilled workers, and you have less than k, your n number of masons output will go down because that combination is going to fail. This you will understand when you are working physically at project site. You have, let's say, drafters. You go to a design office where drawings are being done. You have less number of drafters and more number of designers. What would happen? The designers will give some calculations and work out some scheme for the reinforcement or for the structural design. Give it to the drafters. Drafters will not be able to create the drawings. So what could be the solution? The solution would be making your designers capable of drafting the whole scheme as well. If your designer knows how to run AutoCAD or whatever design process, whatever engineering drawing process your office is applying, if you are able to do that, you will be able to deliver that result. So all that, first the problem has to be understood and then its solution has to be found out based on that problem and the constraints. So these are basically the schemes which are there. The presentation will come to you, so you will understand that. Constructing a mathematical formulation. Obviously, you need to know that what is going to be the process, and that process means you'll have to have the numbers behind it. You can't simply say that fine, I need more workers. You basically need whatever is the deficit, so many numbers more so that your complete composition is full. And that is what you work out on a mathematical formulation. There are productivity, there are quality requirement, and there are safety requirements. But when you are going for construction business, there are three primary fields and windows where you are getting in: safety, quality, and productivity. All those require mathematical formulations somewhere, sometime. Please be very, very clear about those. When I'm talking about a construction application, the engineer's role is to identify the core construction requirements, identify the primary deliverables from the analysis of requirements, identify the constraints, select the working methodology on the basis of objective, constraints, and time frame available, engineering of different components of selected methodology. So if you are able to deliver this or do this, nothing like it. You are a super hit engineer. If you are not, you need to cultivate this within yourself. And that is what our business is. We want to make you that kind of engineer. The role of engineering institution and faculty members. Here comes inputs from your teachers because you're still studying with them. Induction of sensitization activities in regular about the industrial requirements for students, collection and assimilation of inputs about engineering needs, sensitization workshops, student-led webinars for spreading the knowledge to more students, interaction of students with the industry, institution alumni for cultivating the knowledge base. Stakeholders could network with CIDC for building their capabilities and network. Basically, what is needed is, say you are living in city ABZ. In ABZ, naturally, if it is a city, there are bound to be buildings, there are bound to be infrastructure, there are bound to be roads, everything has to be there. Look at the things around you. Try to find what are the requirements, what are things being done. Go to those people who are actually executing these works and let the students learn that. for industrial placement. If the faculty members or the institutions are facing difficulties, they can work with CIDC, and we would be very glad to place all of you into proper institutional internships. Now coming to the last part, or the second last part, there are some sample problems which I'm posing, and then I'll be giving you the solutions for that. One problem, or rather, first we start with this. Have a look. You have studied engineering. This is a video from one of our partners. The essence is that whatever this professor was trying to do is something which is being fed to you as engineering training. But this has to be actually applied. You need to understand that physically this is the structure which you're going to face. And this is how these are the problems you're going to solve. If you're going to do that, you need to know how that machine is moving. Okay, just telling you that it's going to rotate like this, or it's going to turn like this, or it's going to come up and down, you might not understand. And as depicted here. So I'm giving you some problems, and let's see what are the possible solutions. Let's say there's a water pipeline which has to be created. The water planner wants to make sure that there's enough water coming to town through the pipeline that leads that feeds in the river and brings water to the water treatment plant. What would be his objective? Kya chahega? What would he want? Now try to think what elements would condition or constrain this objective that actually push the decision makers to move in the direction contrary to that objective. Say you require, for an example, uh, maybe 70 million gallon per day, MLD, okay? And I'm giving you a number which is being pumped in from River Kaveri to Bangalore. Now, if you require 70 gallon per day, gallon per day, that basically means that your pipe size will be defined by that. You can have a larger pipe, you can get more water, so you don't have to run your pump for the whole time. You have a smaller pipe, you will require to run pump for a more longer time. So depending on what are the constraints and what are the issues, you will be planning your pipeline, what size you need. Okay. In this case, the objective is to maximize the amount of water coming into the water treatment plant. Water treatment plant also would have some kind of capacity. The problem is the constraints. For instance, there is a budget that will restrict the ability to have a very big pipe. So the pipe diameter will have to be conditioned by budget. The bigger the pipe, more expensive it is. Another constraint comes from the fact that the water treatment plant has a restricted capacity as well. So it is pointless to have a lot of water which cannot be treated. So what would happen if you have a smaller pipe? Your plant is going to run like it will not be receiving enough water for its operation. And if it's a very large pipe, the water will be overwhelming about water treatment plant. So all those constraints and limitations are there. This is what defines what size of pipe you'll be making. Another issue, another question. As an airport manager, you perceive that the airport needs to go through rehabilitation. This requires soil exploration to determine whether the weak segment of the pavements are. This also requires measurement of the thickness of the pavement in order to make sure the strength is adequate. These two elements can be tackled through sampling and boreholes. Finally, you need to measure the surface skid resistance to ensure safety. You know, your maximum budget is $1 million, for an example, for getting the job done. What could be your objective and constraints? वो काम मालूम है कि तुमको बोरहोल करके पता कर सकते हो. $1 million is available with you. So what? The airport manager would want to minimize the total cost, and in this case, constraints will be to make sure the strength of the pavement is at least superior to some minimum value. You will define a benchmark or a threshold value that everywhere your pavement strength is more than that. The other constraint will come from the skid resistance of the surface to make sure you warrant certain level of safety for the planes that are landing or taking off. If your pavements are not strong enough, the planes while landing can crash it, while taking off can also crack it. A possible alternative of this objective is to maximize the strength of the pavement, and the skid resistance and budget becomes objectives. Alternatively, you can have maximum skid resistance as an objective while constrained by minimum budget and minimum overall strength. There are several problems are posed here. A road maintenance, it has a solution. A foundation engineer, for foundation engineering, there is a question and then there is an answer. So all these have to be understood. I'll be sharing this presentation, so go through them and understand it. The basic issue is how do you go about it? So now, in conclusion, what do we say? Engineering is a wonderful profession, essential for the society at large. Without engineering, nothing is possible in the world. Individuals practicing engineering need to have the basic understanding of fundamentals, as we discussed. Engineering profession is aimed at providing solutions to given problems or solving issues by applying the fundamental knowledge that was pointed out in the last point. The role of engineering in industry is quite critical for the success of industry, and engineers are needed to provide solutions to overarching problems, as I have exhibited here. Engineers need to be thorough in their basic concept, their application in the field, risks and challenges facing the situation, and finally the modes to arrive at solution of a given problem. For everything, you have to have the basic understanding. So, such understanding depends on the theoretical as well as practical knowledge. Obviously, you need to have the basic understanding of theory, and then how do you apply it on the ground? Primary source for theoretical knowledge are the engineering institutions, and students undergoing training need to receive knowledge as much as possible from their teachers and professors, and it should be as best as possible. Not as best, I should say, as good as possible. For application of this knowledge in industry, they need to clear-cut exposure of the industry. NLIP is the initial exposure that is being provided online today, or like you are in the 6th batch. Once the learner undergoes NLIP, he or she needs physical exposure of the industry via internships, go to an industry, learn things. Timing of NLIP and physical internship need to be scheduled in smart manner so that the students post these programs could get opportunities for receiving the clarifications for their academic guides. Like when you go for, like you are participating in this program, once you complete this program, then you go back to your professors and ask them that this is what I have learned. Please explain what is the meaning of this. They will guide you, and by that guidance, your understanding will grow. Hello? Lecture there. Students also must have industry linkage via student chapters. so that opportunities of interactions with industry captives is available to them. Recently, we had a lecture of for subsurface tunneling by the project manager of Bangalore Metro, and it was online. People could have joined. You need to have those kind of understanding and those kind of interactions which CIDC provides from time to time. These opportunities would enable them to enhance the practical knowledge and therefore could be pursued vigorously, I would say. I have not written vigorously here, but they should be pursued vigorously. Chapters could be in the field of interest, and faculty members could provide proper guidance if required. CIDC network could also be accessed for such actions. You can come to us, and we will work with you to provide you solutions. The last word. Scientists dream about doing great things. Engineers do them. Internships convert scientists into engineers. You are today's scientists. You are studying so many things. Science, science, science. Make them practical, practical, practical. Let us work together to inculcate those capacities within you through internships. So that is the last part or conclusion of my presentation. Now the floor is open for discussions. This presentation will come to all of you. If you have any questions, you want to talk, please join me. See, one basic trait of engineer is inquisitiveness. Ask questions. If you don't ask questions, things will not be clear to you. बैठे रहने से बात नहीं बनती है. Nobody wants to say anything? Unmute, unmute. Chandru Dharmaraj. Chandru? You are the first one on this Google page. So, would you like to speak something? Would you like to ask any question? Krishna Tondepu. Krishna? Nivetha. Rashmi Rao. All are very clear? You know, you'll be receiving some assignment out of this presentation. And if you don't ask questions now, and you are unable to respond to the assignment, you'll be at loss.
No question, sir.
Why? Why, Rishikesh? Don't hesitate. अच्छा कोई बात नहीं. I think Mishra ji, please take it over. These boys and girls, they've understood whatever I wanted to convey.
Sir,
Think.
I request all interns to interact with sir, because it is rare opportunity for all of you that you have expert like Dr. Professor Niranjan Swarup sir. So if you have any query, any question, please come forward and interact with sir. As sir guided you that if you will be in touch with CIDC and I and FTT, definitely they will may have very good opportunity for better knowledge, better skill, and to be fit for the industry employment. So please come forward, come without any hesitation, and interact with sir. Sir is available. So if you have any question, please come forward. Please. Sir, this is the first session, so students are not very, let me say, they're very vocal. So, now we may give them another chance in the next session to interact with you. In your next session, I am expecting that they will have more questions, more queries, and more points to discuss with you, sir.
Sure. Basically, you people need to be confident. You people need to be dead sure.
Sir,
If you're confident and dead sure, you'll be successful.
sir,
If not, sorry.
sir. Sir, they are in the way uh, completing the engineering and becoming an engineer. So they are learning to have the characteristics and the personality of the engineer, sir. So definitely they will come forward in the coming session, sir.
जी ठीक है
तो सर अब हम लोग सेशन कंक्लूड करते हैं सर. थैंक्स अ लॉट. थैंक्स फॉर गिविंग यू द complete insight of the engineering and the expectations of the industry from the engineering students. So really we are very thankful to you, sir, for your time and knowledge sharing with our interns, sir. Thanks, sir. Thanks, sir.
जी ठीक है सर